Hello, we're going to continue on a review and we're looking at 1.5 now. You've all seen this future value formula compound interest where P of t equals P naught times parentheses 1 plus R over N to the power of NT, where P naught is the principal, which is the original amount of the loan or the original amount of investment, R equals rate, T is time in years, and is compounding period. And a reminder, a compounding period is how many times per year we calculate interest. For example, if we say annually, of course that's once a year, so N would equal 1. Monthly, that's 12 times a year, so N equals 12. Weekly, N equals 52. Of course, daily, N equals 365. Then we have continuously, which we will hold off on. Okay, so let's start. We're going to do a little word problem as an example. And we're going to check out what happens when we do the same problem annually and then we do the same problem monthly to see what happens. Okay, so we're going to invest $1,000, all right, into a future value formula, compounding interest at 2% rate. And we're first going to compound annually. Okay, so we use our formula right here. P of t equals, we're investing 1,000, that's our principal. 1 plus the rate is 2%. We have to change that to decimal. N compound period we said was annually, so that's just 1. To 1 times 3, because, I didn't say 3 years. Sorry about that. Okay, times 3. All right, so when we calculate that, using PEMDAS, we have to do the division first, add the 1 to the power of 3 times 1,000, and we get $1,061.21. Okay, let's see what happens when we do it monthly. So we're going to do the same problem now, but we're changing the compounding period to monthly. So right here, N is going to be 12. Then we have N times T, so we have 12 times 3. Okay, so when we do that, we notice that we have $1,061.78. So you can see when we compound more, here we compounded once a year, here we compounded 12 times a year, and it went up from 21 cents to 78 cents. Now when you're working with large sums of money, this is large sums of difference that will happen. Okay, so now what about continuously? Remember, continuously we have a different formula for that. I'm going to put that formula right up here where we have some room. And that formula is P of t equals P naught E to the RT. Okay, so this is continuously. If you can imagine, like every second or nanosecond, something like that. Okay, so let's use that formula now with what we have. So we have P of t equals 1,000 times E to the R, and the R is 0.02, times T, 3, and we would multiply those, take it to the power of E with our calculator, multiply by 1,000, and we would have $1,061.84. So we see with continuously, it even grew larger.